many of us, glass is taken very much for granted. Yet a man-made material, glass possesses a certain indefinable quality. It may be a clean-cut honesty of purpose, or the eloquence of the designs and artistry to which glass lends itself. The skill of a master craftsman shapes a piece of lead crystal into a vessel of true elegance. Its depths seem to contain pools of light. Its surface textures fascinate the eye. Look at it for long enough, and one would say it had a life of its own. Lewis Carroll went beyond the looking glass to create a world of the imagination which, too often for comfort, resembles the one in which we live. The looking glass brings us face to face with ourselves and leaves us to make of the image what we may. From his first knowledge of glass, man has seen its use as a challenge to his skill and ingenuity. In the hands of an expert, glass becomes completely plastic, and designs of infinite scope become possible. The craftsman in glass has developed many techniques to realize the potential of his material. Clever use of carefully prepared masks is a preliminary to the technique of sand blasting. The mask, a strong paper of the impact adhesive type, is fixed to the glass. The design is drawn on this paper and then cut out. Sandblasting is a versatile tool in the hands of the glassworker, producing a wide range of decorative stipples and surface finishes. This fine glass mural of Westminster illustrates the effectiveness of other techniques, such as acid etching and coating with metallic oxides. Contemporary architects show a growing appreciation of these treatments in glass, and present-day building design benefits greatly from its presence. Man's adventures into glass range from the mundane to the magnificent, from vessels of utility to enduring works of art. Stained glass suggests a world of ordered calm, forming as it does part of the fabric of our great cathedrals. Stained glass was non-existent before the Christian era and is essentially an art of Western Europe. Working methods have changed little over the centuries, for by its nature, every stage of the painstaking work must be carried out by hand. The ultimate beauty of stained glass depends a good deal on the skill and judgment of the glazier, who cuts pieces of carefully selected glass to the original design of the artist. Assembling a stained glass window is like putting together a jigsaw. A permanent jigsaw in this case, for every piece is secured in position with strips of lead. Imaginative new techniques are being developed in stained glass. Slab glass, set in concrete, is a radical departure from the formal styles, but the jewel-like effect still retains the time-honored qualities of the older craft. For thousands of years, beacons and lights of one kind or another have guided seafarers. Keeping a lonely vigil develops a special affinity between a man and his light, and he tends it with patient care. From here springs the warning beam of a sentinel of the sea. The finely worked prisms represent optical perfection. Daylight fades, and another round of duty begins. Brilliant spectacle of light and color. This is glass in a festive mood, symbolizing all the gaiety and excitement of a carnival by night. It has been said that of the 5,000 years history of the glass industry, the past 50 years are the most significant. Certainly, since the advent of electric lighting, there has been a vast and rapid growth in the glass bulb industry. These electric light bulbs have been made by the most highly productive glass-forming machine in the world. It produces bulbs at the rate of 2,000 a minute and turns out an amazing variety of shapes and sizes. An essential adjunct to modern electric lighting is the glass lampshade. And in this field, the skill of the traditional glass blower comes into its own. The blowpipe is a simple device, just a hollow iron tube. Yet in the hands of the craftsman, it makes possible the creation of an endless variety of hollow glass objects. Off-hand blowing has been practiced by glassmakers for over 2,000 years, and present-day craftsmen still use methods which, in origin, are credited to the Phoenicians. Many individual skills and talents are involved in the production of quality glass, and proper finishing of the rough edges is just as important as the more refined treatments. Glass is a perfect medium for artistic expression. Even the more commonplace objects gain added appeal through the use of enameling and other decorative methods. Until it is fired in a kiln, the enamel remains soft and easy to remove, thus enabling various effects to be created on the surface, using specially shaped scribing tools. Contemporary tastes have created a big demand for this type of shade, and simple mechanical aids help to keep the design consistent and increase productivity. There are styles requiring more individual attention, where a keen eye and a steady hand are the prime prerequisites. The inherent high standards in traditional crafts like this do credit to the material they use. Glass has an acknowledged place in an age of spacious living, ideally interpreting the bold styles of contemporary art with a power of expression all its own. We of the 20th century would think a world without glass inconceivable. Take away glass and you remove one of the most vital and exciting dimensions of our lives. A modern city presents an inspiring spectacle of steel and concrete. Towers of glass, climbing ever higher in their quest for space and light, and creating the need for new techniques in the maintenance and cleaning of vast areas of glass. Already well established is this roving platform, a hydraulically operated machine which dispenses with the usual scaffolding and cradles. All movements are controlled from the platform by the operator, using pedal controls to leave his hands free for working. Talking of glass and water, let's look at a more relaxed environment. Glass is impervious to liquids, gases, odors, steams and vapors, and it provides all the essential requirements of safety and hygiene. The pleasures of indoor swimming owe much to the wide use of vitrolite tiling, and armor plate observation windows serve to attract the non-swimmers. Our health and well-being, our work and play, all profit through the advancement of glass technology. Glass has been in the swim for long enough in providing homes for the occupants of our seas and rivers. We can't all own a diving bell to visit them in their real habitat, but even so, this is a safe and pleasant way of making their acquaintance. In sight and sound of Southampton and her ocean queens stands one of Britain's biggest and most modern power stations. The economics of generating power affect us all. There's a constant effort to improve efficiency and keep down costs. This is where one of the more sophisticated glasses, borosilicate, comes in. Borosilicate has a high resistance to thermal shock. The installation of these 25-foot-long tubes in an air heater, serving the generating equipment, has resulted in a great increase in efficiency over the metal tubes previously employed. These glass tubes have proved to be clean and corrosion-free, conserving vital heat and reducing maintenance costs. Chemical laboratory ware is the special province of borosilicate glass, and there's a fascinating world to be explored. Beautiful fantasies in glass. These delightful creations typify the work of the 19th century artist in fine spun glass. Glassworkers often indulged in these flights of fancy to satisfy popular tastes of the day, though they were capable of more serious work. Glass is an amalgam of many things. Volcanic glass, or obsidian, is as old as the earth. The Englishman George Ravenscroft developed flint glass in 1675. Lead oxide is the ingredient which imbues the glass with all its characteristic brilliance and beauty. And what chemistry leaves out, the craftsman puts in. A bizarre marriage of old and new. Tyrannosaurus rex, the largest flesh-eating dinosaur 90 million years ago. And fiberglass, a 20th century miracle. Part of the backbone and feet are the actual bones as discovered in Wyoming, USA. But the greater part of the 18-foot-high skeleton has been reconstructed with bones cast in glass fiber. The ancient Egyptians were the earliest makers of glass in fibrous form. They produced threads of no more than 1/1000th of an inch in diameter. The thread in a modern alkali drawing process is several times finer than a human hair. And some hundreds of these threads are drawn down from the furnace at high speed and grouped together to form single strands of glass fiber. The thread is stored on cakes, ready for further processing into finished reinforcement materials. Some is used in the form of rovings, precisely wound bobbins of glass fiber, ready for use in producing tubes and pipes for industrial plant. Of special significance is fiberglass reinforced plastic. Major users are the automotive, aircraft, and shipbuilding industries. The basis of fiberglass reinforced plastic is a glass fiber matting formed by feeding the strands into chopping units, which cut them into short lengths. The chopped strands are dropped on a moving conveyor, sprayed with adhesive to hold the mat together, and finally dried and wound off in rolls. Forward-thinking designers are finding new and exciting uses for fiberglass. But exciting things are also happening in another sphere. The astonishing strides made in speed and travel have put safety glass in the forefront of our essential industries. There are two types of safety glass in general use, toughened and laminated. But the first step in either process is cutting the glass to the required shape. This is the erasing treatment, which in layman's language simply means chamfering the edges of the glass. Next comes the toughening furnace, where the glass is heated to softening point. Out of the furnace and swiftly into the die bender, which curves it to shape. Now a rapid cooling between oscillating jets of compressed air. Emerging from a cooling tunnel, the screen is now at room temperature and can be checked for size and shape. The most important point for checking is the stress pattern created by the toughening process. Inspection by polarized light makes this clearly visible. Laminated screens are made by bonding two matching sheets together, making it possible to sandwich a multi-wire invisible heating element between the two glasses. The bond is actually a strong plastic interlayer, and at this stage of the process, everything must be clinically clean. Dust or dirt from the atmosphere must not be trapped between the glasses. The heat and pressure generated in a special chamber called the autoclave welds together the plastic interlayer and the sheets of glass. The result is a completely transparent screen. Manufacturers are constantly engaged in research work to keep their product abreast of new developments. This is the Triplex GTS, a car specially designed to explore modern adhesive glazing techniques in safety glass. Tests are being made on energy-reflecting films and photochromatic glass, which changes color in bright sunlight. The knowledge gained in this research program will lead to new and higher standards of visibility, safety, and comfort. And not just for the road user. Safety glass is playing an increasingly important role in the field of aviation. The higher takeoff and landing speeds of jet aircraft increase the dangers of impact by birds. And to resist penetration, the screens of civil and military aircraft are up to 2 inches thick. Pilots need unrestricted vision. In addition, aircraft windscreens have to cope with great extremes of temperature. All this and more, safety glass provides. Skill and resourcefulness, plus modern technology, have brought glass to a high peak. The continued expansion of the industry promises even greater things. Modern technology and design make heavy demands on the materials that they fashion. But glass, at once practical and beautiful, has the versatility to meet and satisfy the exacting standards that the world of tomorrow will surely bring.